Thank you very much. Just the first caveat before I start, this is very much work in progress, so really feel free to make comments, suggestions, and also interrupt if you want. I'm also happy to be the last one in this session because I think that previous presentation they introduced and discussed some interesting topics that are also related to this presentation. So the interest here is to study the effect of technological change, which is a phenomenon that has characterized our societies in the last years. So think, for example, about the introduction of robots, computers, artificial intelligence. So this big phenomenon has changed also economic systems and our societies down to the very deepest roots of our society. And this may translate also on some effect into educational outcomes. So we know from economic but also sociological literature that technological change can have an impact on economic system, and they can radically mutate and change the economic system in Western countries. So think, for example, about the introduction of computers, automation, all these new technologies that have shaped not only the way we think about work, but also society overall. And in the literature we see that this shift in technology can have also some distributional consequences, and these affect labor market dynamics. When I talk about distributional consequences, I think about the case that we have some winners and some losers of these processes. So people in some specific occupation, because of the characteristic of this occupation, they will be more exposed to the change. So for us, they will be the winners if they are more complemented by the new technology. Think, for example, about engineers or people that have a strong education premium, and therefore they are more complemented by the new technology. So for us, they have better career prospect. There are more dynamic new jobs, and these people can work in these new jobs. While other people, on the contrary, they're more the loser of technological change. So think, for example, about people that are more substituted by the new technologies, and therefore they will lose out from the process. So for us, they either lose their job, or they will work in an industry which has less career prospect, and overall less opportunities to find a decent occupation. And we know that these structural economic changes can have effect not only on the economy, but this economic effect can propagate into a broad area of other social dimensions. So there is an expanding literature on this. There's a very interesting work by Berger and Excel, and they saw that the higher the exposure to robot adoption, the lower social mobility in the United States. Also, there is another work I'm working on with other people in Bocconi and National University of Singapore. We see that basically higher exposure to robot adoption, higher technological change, and also there are changes in labor market institutions. So for example, union density is going to become lower, and therefore union and collective bargaining are affected by these changes in technology and in labor markets. But also effect on health condition. So you have this big shock, economic shock, can be globalization, can be technological change, and people that are more affected, so the so-called losers are going to have more stress, and they're going to have some also health problems. And finally, there's also some work on the effect of these changes on political behavior. So it has been found that at least a part of the increase in the support for populist radical right parties can be explained by some economic drivers. So exposure to robot adoption is empirically linked also to voting behavior, and therefore these phenomena are really politically consequential. So just to provide a bit of background, this is not a new story. Also in previous century there was some concern about the threat of technological change. Think about concept by Keynes, he thought that automation will eventually lead to technological employment. Or also this quote by Basilio Tieff, labor will become less and less important. More and more workers will be replaced by machines. I don't see that new industry can employ everybody who wants a job. Now, luckily, these very pessimistic predictions have not come to pass, because this is an old story, right? We always had machines, these changes, and we haven't seen these, really structural increase in technological employment. This doesn't mean, however, that there are some consequences, and we have seen these consequences. So there is a strong impact. We have seen, for example, that automation has contributed to an increase in wage inequality. So automation is leading, at least in Western countries, an increase in the polarization in wages of different workers. There's also a polarization in employment. Usually this is driven, for example, by the fact that people in traditionally middle-class occupation, a lot of these jobs are disappearing. So a lot of people that traditionally have been working in middle-class occupation are either going up, so before, perhaps they have some sort of education premium that allow them to go up, but a lot of these people, they will go down. So there is an increase in polarization. And it seems that people that are more affected are not only people with lower education, but more specifically people that are characterized by more routine-based occupations. So even people in the middle class that have perhaps an average good level of education, but they are specialized in occupations that are really routinely based, these people are being substituted by new technologies. And while on the contrary, jobs that involve more non-routine tasks are more difficult to substitute. So for the moment, they are less affected. Although we see that probably also these less routine occupation in the future, they will be more affected, because machine learning or robotics now are taking computerization really to the next level. So this is going to affect also occupations in the future. So now, what's the role of education? We've talked about technological change, but we're interested also in the role of education. Well, I think that education is really a key element. I cannot stress this more. So education and training more in general are really the true response, the true Ubiquitous system to cope with these new challenges, right? So the big question, however, is are the current but also future workers able, because of education, to cope with these new challenges? So this is a very, very big topic, and here I just want to provide some preliminary evidence, but more introduce this new research agenda, and also I'm looking forward later to the discussion. So in this new research agenda, I want to distinguish between two different levels of analysis. So first we can think about what I call the first generation. So this population is the population of people that nowadays are already working, or are in the labor force. So these people are directly affected by automation because their occupation perhaps is threatened by new technology or is complemented by new technology. So these people are directly affected. And when we talk about the role of education, we talk, for example, about issues of professional integration. We want to retrain the workers that are displaced. So you see that education has an important role, and we can answer many different research questions regarding, for example, heterogeneous displacement and different degrees of rehabilitation. This is something I'm very much interested about. But the evidence that we present today, although it's very preliminary, is more on the second generation. So this is the population of people that are not working yet. So think, for example, about students. Students nowadays, they are not really directly exposed to automation because they are not working. But they will be the ones in a few years to face this new changing world. And also these people can be affected indirectly through their families. Like we've seen in the first presentation today that there's there's a strong association between the family background and the student education outcomes. So if the family background is shaped, is changed by these changes in the labor market, but also we're going to expect some repercussions on student ability, to acquire the skills that are needed. So, this was more a general introduction. Now we'll just provide some preliminary evidence on a much more specific research question, which is the following. I want to understand the effect of exposure to automation on the educational performance of students. So this is more on the second population, right? We want to understand more what is the effect of technological change as an exogenous, like contextual change. We want to see if this is associated to the performance of students. So if this change in the economic condition can have some effect also on the performance of students. And just to think about the mechanism of this, you can think about automation as something exogenous or external to the student. But this, as we saw, is going to have some strong effect on the economic occupational condition of workers. Workers as a part also of families. So we expect automation to shape the occupational structure of students, of workers, and therefore we have some families, so let's say the parents that are working in more automatable occupation, then these families will experience perhaps a loss in their income, a loss in their career prospect, a better health condition. So we're going to have some distributional consequences even across families. And we saw today, in different ways, the condition of families can have really an impact, can really determine student outcomes. And therefore this is something that is really worth to investigate. So in this paper, as I say, really preliminary, so feel free to make comments also on the way how to progress. First, I will just provide further evidence of this link between economic situation and student performance. Here I will just focus on math and language, and then some first attempt to try to estimate the impact of exposure to automation on student outcomes, and specifically in the INVALSI test in math and language. So now, just the first very descriptive evidence. Here we see that the occupation of your parents matter. Basically, the occupation of your parents is more like high skill, like managers or professional. You're going to be characterized by better performance on average in the standardized test scores. While on the contrary, if you are more in a less skilled occupation, as a student you're going to be characterized by lower performance. It seems also there is some increase in the gap between some occupations, but this needs further investigation. So here, I think it's important just to provide further evidence of this link between the economy and the student performance. We can just regress educational outcome on economic growth. This is just to provide further evidence of this link between the situation in which students are, so the context, the economic context, and to see if there is some association with student outcome. And therefore, I take economic growth in the years previous to the educational outcome. And we see, I do not want to talk causally here, this is just more descriptive evidence, but just to provide further evidence of this link between GDP growth and performance in standardized test scores. So we see that in the provinces in which there is more GDP growth, then you are going to experience also better performance in terms of standardized test scores. You see that the coefficient is positive and significant. Now, this first evidence instead of the other part of the story, the one I want to progress more on, is on the exposure to automation. We want to see the effect on student performance. So here the first equation is the only one we present today, but others will come soon. So I hope that there's interest on this, is to try to understand the relationship between educational outcome and exposure to automation. Here, how do we define automation? We just take a typical measure of exposure to robot adoption. So we basically take the share of employment in a given area and sector, we divide by the total share of employment, and we multiply by, this is the delta, the increase in robot adoption divided by the employment. Just to provide the intuition of this measure, basically, the more in your country, is Italy, the more some robots are bought in a given industry, and the more the region in which you live is specialized in that industry, then the higher the exposure. So this means that if I live in a region that is really much specialized, for example, in textile manufacturing, and in this year there is a lot of new robots in this industry, then I'm going to be more exposed. However, you may think that, well, if you're going to investigate this can be really, there might be some problem of omitted variable bias, right? Because people that, not people really, but firms and regions that are buying more robots and industries that are buying more robots perhaps are also the same regions that are experiencing more economic growth, or there might be other drivers. So in order to account for this, I will also instrument, this is an approach that is quite typical, it's becoming very popular in the literature, I will instrument this exposure to automation also to the robot adoption in other European Western countries. So the idea is that I will try to isolate the part of increasing robot adoption that is more exogenous, that is more coming from, try to isolate more the exogenous variation. But if you want, we can discuss more about this later. So now these first preliminary results that I was introducing, we see that, let's just look at column 1. This is the OS estimation. We see that robot shock is negatively, but not statistically, associated to performance in math. Perhaps this is due to the reason I was saying before. So there is a lot of problem of omitted variables. When we take a more, I would say, robust approach, so we try to isolate a more exogenous variation in robots that are not driven by the regional context, the Italian context, then there is a negative, much more statistically significant association. And this is true also for language score, although the degree of statistical significance here is not the same as math score. So now I'm going to conclude. This is very preliminary, but there is some preliminary evidence of the fact that exposure to technological change can have an impact on educational performance. And it seems that we think about this parental job polarization in occupation. This might translate also in a polarization of children outcomes. If the children that are in families that are more exposed, if they are the ones that are exhibiting also worse performance. And if we believe that families that are more exposed to automation are also the one in which kids are performing worse, this means that there is a failure of the education system in providing the new competencies to those who need it the most. So the idea is that a vicious cycle by which if we think that students that are living in more exposed area, and therefore these people are the one that will face a bigger problem in the future, if these people, because of the contextual situation, are also the ones that are less able to acquire the competencies, then this is going to reinforce and there's going to be a vicious cycle, and probably also can be a mechanism of intergenerational persistence of inequality. Thank you. I'm really looking forward to comments and suggestions.